Industry Connect Part 4. I take the privilege of MIT to welcome the eminent speaker, Mr. Ankur Goel, in the webinar. Now, I would like to request Mr. Naveen Kaushik, IRO, to introduce the speaker in the webinar. Naveen, sir, may I request you to introduce the speaker?
Yes, thank you, Ayush. Very good evening to all of you. And on my personal behalf, on behalf of MIT Meerut, I welcome all of you to this fourth series of Industry Connect. And today we have in between us Mr. Ankur Goel. He is a senior manager in Saxo Bank, and he has a vast experience, more than 10 years in industry and banking. He'll be delivering today's session on the overview of microservices using .NET Core. So, Mr. Ankur Goel, please continue the session.
Yeah, hi Naveen, Kaushik and Ayush Singhal. So it's my pleasure to take a session of MIT Meerut College. So it is a prestigious college, and Ayush Singhal is dear to me. So he invited me to take a session for MIT Meerut. So I accepted his invite, and I'm ready to give that session. So I will introduce myself. I am Ankur Goel, and I am working with Saxo Bank for at least 5 years as a senior developer, and my designation is senior manager. So I take a lead in the developing the software for Saxo Bank. And I have 14 years of experience in .NET development and the .NET platform. Currently, I'm working on the microservice and Azure environment. If you have heard about the buzzword Azure and the microservices, so I take my privilege to take the session on the same topic, microservices using Azure and ASP.NET. So may I know if everybody know about microservices, or everybody heard about this word microservice and ASP.NET Core, or maybe Azure? What does my audience have those kind of skills or heard something about these topics? You can give your note by raising your hand, or maybe by doing some activity on the Zoom. So I'm assuming everybody is aware about these things. So I will start my topic from my presentation. I prepared some small presentation about the microservices. So first I will try to explain what is service, and then what is microservice, and then I will move on to the Azure and the .NET Core. So concept of services is like, if I need, let me share my screen with you guys. I think my screen not visible to you. Is my screen visible to you guys?
Yes, sir.
Okay, good. So my topic, again I'll tell you, like my topic is microservice with .NET. So I will start with the question, what is microservice? Let me zoom it. Okay. So what do you mean by a microservice? So basically definition of microservice is it is a service which has the single responsibility pattern. If you have heard about single responsibility pattern, so single responsibility pattern is that it will do only one activity in its lifetime. Suppose if I will tell you about a mechanic. So if a car mechanic is there, so he will repair the car only. It will not repair the bike or scooter or maybe bus. So car mechanic has a single responsibility to do the activity. So same kind of the activity will be there in microservice. So microservice is designed to do some kind of special activity. If I will tell you about in terms of software design pattern, so it may be like logging your messages, error messages into a log table, or maybe SQL server, or doing some special activity. So my service will be like a logging service, because logging service is doing only one activity, logging the messages to some kind of persistent medium. So persistent medium will be like database, maybe file structure, or maybe some storage into the cloud. So it will log those kind of messages to my persistent medium. So this will call a microservice, because it is doing only one activity. We are not overloading other activity to that microservice. So question is that, like, why we are using microservice in these days? So microservice comes into the picture by doing the load balancing, or like you have heard about the recently you got the result of CBSE. So we people, we are a student, or and whenever there is a result coming from CBSE, so CBSE site is crashed due to the overload and maybe the overburdens, like some more requests are coming to the server, and server is not able to handle all those requests at the same time. So server crashes. So that is kind of like a service is doing a lot of activity at the same time. So service is not able to provide the request, is not able to process the request, so it crash. So in the software architecture, we introduce microservice. So microservice will be like, we will deploy that microservice on a platform which is scalable. Scalable means like we can increase the number of processor or maybe CPU at a runtime. Like if CBSE is going to publish the result on Monday, so on Sunday CBSE will introduce new server by using the microservice architecture, and service will be up and running at the time of when a student will be checking their result on CBSE result site. So that is the concept. We bring microservice into the picture to avoid the crashing, runtime crashing at the time of the more load. So this is the basic idea of introducing microservice into the software architecture, to avoid the runtime crashes and to provide the scalable environment. Scalable means like you can increase the load at the runtime. Like you can increase the number of CPU at runtime, or you can decrease the number of CPU at runtime. So increasing the CPU at runtime increase will your cost, and decreasing the CPU at runtime, it will decrease your cost of maintaining the hardware. So like the big corporation or like big institute save cost by doing this thing. Like suppose at the load time they need 10 server at a time to provide their support to their softwares. So they can increase the cost at that time, but at the lean period when there is no use of those servers, and the student are not there in college, or maybe employee are not there in the office, like in this case we are in the corona period. So company server are not in use a lot, so they can decrease the number of available server at any time by using microservice architecture. So this is the overview about why we use microservice. Now I will move to the second one. Uh, how you will call a service a microservice? So if you guys work on APIs, like how you define an API, so there is a basic structure to define a API. So here is an example of a API value controller where I am getting some values from the backend. So here I hard coded those value into my function get function. So I can do some kind of like the services, backend services also, to get the data from the backend service, like the database, or maybe I'm getting the data from another service. So will you call this architecture is a microservice? I will say definitely it is not a microservice architecture, because it is a simple controller which is getting the data. So we wish to know how we are getting the data from the backend. Suppose here I have hard coded value 1 and value 2. So if I have to get this value from backend service, how I will do that? So in that case, I will make a another service which will give me the value 1 and value 2, and that service may be a window service, or maybe a microservice, or maybe a web API service, any kind of service. So which will give me the data, and after getting the data, I will expose those data by this endpoint, get endpoint. So guys, am I fast or am I slow? So you can let me know in between also. I will try to be slow if I'm going too fast. Yes, Bharat, you have some question? Bharat?
No, sir. No, sir.
Actually, you raised the hand, so that's why. Okay, no problem.
No, no, sir.
Okay. So definitely this is not a microservice architecture, because we are not getting the data from the backend services. So for designing a microservice, I have to design a service on on .NET Core platform. That service will be again giving me some data. So I will show you how to design a service into the ASP.NET Core after this demo, after this PPT. Okay. So I'll show you how microservice works. So have you seen Onion in your life, how Onion works and how Onion is designed? So Onion basically has a layer on top of each and every layer. Like there is multi-layer, so we have to remove one layer, then we remove second layer, then we remove third layer. So suppose we have an onion on the core, we have a service. So that core service will be a microservice, and the layer will be another service on that core. So I'll show you in this diagram, like we have a service in the core, and that is a microservice. Then we have a layer on that service, and maybe that service will be a logging service, like we have a say logging. Then we have a another layer on that logging layer, that is metric monitoring. And then we have another layer on that monitoring, that is security. And then we have another layer, that is protocol. So protocol is a last layer on any service, because we access service on the basis of protocol. We have HTTP, UDP, and TCP. So these are the commonly used protocol to access any service. So generally we use HTTP. So HTTP will be a outer layer on any service. So here I am describing about a microservice onion. So on the core, there will be a service which is called a microservice. And if that service is logging any kind of the data into persistent medium, like the database, maybe event log of the computer, or maybe some file server, so that service log the data by using the logging layer. We have a green layer, that is a logging layer. So logging layer has a responsibility to log each and every log into the persistent database. So we have segregated service responsibility and the logging responsibility. We are not giving the logging responsibility to the service, because if we will give that responsibility to service, so service will be overloaded. So to avoid that scenario, we have segregation between the service functionality, core functionality, and the logging. So over that logging, as I say, there is maybe like monitoring. If we have to monitor our service about like the performance of the service, how service is performing, what is the CPU uses, and what is the memory uses, what is the service downtime, uptime. These are the metrics we use to monitor the service. So we can use that layer to get the service health status. And then we have a tracing, like if we encountered any kind of a problem in our service, how we will find the root cause, and how we will troubleshoot the error, or maybe the problem we face in the service. For that we have a tracing service. So tracing service will provide us the some critical information about the exception, error, and information occurred into the service. So this is a basic architecture of a microservice, how microservice works and how we will design it. And then we have a different kind of the security. Like if I am I'm designing a service, so that service needs some kind of the security. Like anybody cannot come and access my service. Suppose I have designed an email service, so I cannot access other emails because there is some kind of the security available. I can access only my email. I cannot access email of Ayush or maybe the Kaushik sir. So there is this kind of the security I have to implement on my service, but I cannot induce that security into my service. Again, if I will induce it, my service will be overloaded. So I segregated all the responsibility in separate services. Maybe like I design a security service which may be used by another service. So I will give you the example over later. Like this is the onion design architecture. In the later slide, you will get how we can use the security and the tracing in the multiple services. So after doing this thing, so we have like this is 2-3 line definition of a microservice. So if I have to define in a bookish knowledge what is a microservice, so microservice is a discrete unit of functionality that adhere to the single responsibility principle, ask nothing of it host, and can deploy without impacting other service in the ecosystem. So what do you mean by that thing? Like I say, service should have a single responsibility. It should not have a multiple responsibility. Like a student cannot teach at the time of he is studying because he has a responsibility to study, not teach. And teacher has the responsibility to teach, not study. So we can define the responsibility by doing this thing. And the second word say ask nothing of his host. Like it can be deployed on any environment beside any dependency. Like if I have to deploy a service into my say Windows service, so it should not have any kind of dependency. Like it needs some system kernel, it needs some like say the file architecture or maybe the database, anything. So it can be deployed without any dependency in the ecosystem. So ecosystem, like if I have a lot of services on my server, so it will called a ecosystem. So it will not disturb the ecosystem of the server if I will deploy my service into that ecosystem. So this is a basic definition of the microservice. And again, I was saying about the onion architecture. If I have to cut the onion and we'll see where am I sit into the onion architecture, so I will be on the core. So the pointer points to the core. Like microservice is here and we have a layer of other services over it. So if I design a microservice, so how can I discover it? Like whenever I design a microservice and hosted it, so main problem is that how my consumer will discover this service. Suppose if I'm trying to subscribe a service, suppose say about the Netflix subscription or maybe the Amazon Prime. So how the user will come to know where my service is hosted? So there are some platforms like Steel Toe and Eureka which provides the functionality to discover the available services. So you can go to their platform and then they will show you the multiple service available on their platform. So these are the basic attribute of a service discovery. Then logging and monitoring, like in my previous slide, I told you about logging and monitoring. So there is a tool, Elasticsearch, which provides you the functionality to log the data into persistent system and then do the monitoring, like health check of your service. Then we have a security attribute. How we will implement security? We will implement security by OAuth, OIDC, DIY middleware, third-party middleware, Azure. There are multiple library available, or like the library or some packages available in the internet, which provides you the security to do the authentication and authorization in your microservice. And the next attribute is protocol. So whenever you design any microservice, there is a protocol available to use it. So we have HTTP, TCP, UDP. We have a JSON protocol also, and nowadays we are using gRPC. So gRPC is a kind of advanced protocol to do the server to server communication. You can go to the Google and you can read about gRPC. It is a like buzzword or hotcake these days, and it is the advanced version of RPC, remote procedure call. Like if you have studied in your college or in your textbook about remote procedure call, so this is Google remote procedure call, gRPC. So it is a advanced version, and it will reduce the turnaround time between two server. Like I try to call one server and that server responds me with the data, so that turnaround time will be very less in gRPC, and it is more secure. And then we have a configuration is like if I'm deploying my microservice in any environment, that service may need some kind of a configuration to configure the data, like the number of CPU available, number of RAM available, or hard disk size available, or the processor, any kind of these configuration I can define by using the configuration attribute. So again, there are platform available by which I can configure these value at runtime. Then we can check the downtime deployment. Like if I am going to deploy my service into Azure or any hosting environment, so then I can measure how much time it will take to install any service and make it up. Like if I'm installing a software or service on a environment, it will take time to deploy there, then install it, and then to do up the service it will take time. So I can measure that time also, like it takes 15 minutes or 30 minutes to up my service, so that will be a downtime, because at that time my service will not be available. And again, like tracing will give me the like the system monitoring, logging, or it will help me to troubleshoot the runtime error or maybe issue in my service. And about scaling, I told you in the beginning, like if there is a load in my server, like at the time of the checking the result, like a lot of students are coming to CBSE site, so at that time load will be more. So I can scale up number of CPU and number of the server available in my service by doing the scaling. And I can do the upscaling also, downscaling also. Upscaling means like I can increase the number of CPU, and downscaling is that I can decrease the number of CPU. So these are the thing I can do at the runtime. And last is the messaging. Like if I have two service, how those two service will communicate. And or maybe I have more than 100 services, how those services will communicate. It cannot communicate between each other, because if 100 service will communicate between each other, so it will create a mess and maybe my system will be down. So I can put a message bus between my services, and message so one service put the data on message bus and other service will read the data from the message bus. So it is a kind of a queue. You have seen a queue like in your day-to-day life also, like to avoid any mess. So any kind of the system message queue will be implemented. Like if I will go to the bank, there will be a queue to do all the activity, because queue will give me a kind of the persistent, like there will be no queues, though no mess in my system. To avoid that thing, we implement the messaging. And messaging again is kind of a queue. So there is a well-known messaging queue software packages available on the internet, like Rabbit, SQS, Azure, Kafka, PubNub. So these are the messaging queue available. So whenever you design your services, you should use messaging bus or messaging queue to avoid any runtime trouble issue or like the bug, which will give me the like my system will be up and running at all time, because I'm using the messaging queue. Do you have any question right now? Okay. So now, while designing microservice, you should focus on your service only. Like you should not bother about outside of word. Like if you are studying, you should focus on your study. You should not bother about outside of your word. You should do the 100% for your education and study. So same kind of the concept we can apply for our services. Like focus on your designing of your services, and trust your onion layer. Like I can trust on my layers, like it will provide me the security, it will provide me the logging, it will provide me the monitoring. So it is not my job to do the logging and implementing security and to do the monitoring. I will design my service only, and that is enough, and I am trusting my onion layers. So in my ppts I am giving the example of onion, like the layer architecture. So my layer will do the other things, and they have the responsibility to uh, to do their job. So my job is to implement or to design my service, and rest will be done by the layers. And second line is like, let the expert do what they do the best. So that is the thing, like if you are designing something, you should not be an expert, because expert may be somewhere else. So those experts should design their services as they may design, but you should do your work and design your thing, and do not try to be expert, or do not try to be enhance your services. And third point is, use professional grade wheels, do not reinvent your own. So that is kind of thing, like if you have anything available in the market, you should not design it okay, from your own, because it will include time, it will include cost, it will include anything. Like suppose if somebody tell you design a email service, is it good to design an email service in this scenario? This is not advisable, because Gmail is very popular. Gmail is used by everyone. So if you are designing an email service these days, so that will be a very bad decision, because it will not give you anything. So this point uh, is defined by this email service. Like if a service is available which is highly available or highly professional thing, so that you can use the email service from Gmail, you should not design the email service from your scratch. And fourth point is, cloud platform are plentiful, available, and mature. So these cloud platform like Azure, AWS, and like Google. So these platform are very mature. You should not design your cloud platform. You should use these available platform, because this will save again your time and money. And last point is that if your service is buggy or broken, none of these onion layer can save you. Like if you design a faulty service, and you are assuming like other layer will take care of your faulty service, so in that scenario it will not work, because you should design your service at the 100% level, and after that your onion layer can save you, otherwise it will not save you. Like if you are weak, nobody can save you. You should be the strong enough, so that everybody can protect you. So the core focus is that you should design your service 100%, and your service should not be buggy or broken. So I tell you about too much about onion layers and all these things. So I will move to the architecture. So this is a simple architecture where we have a API service. So you can assume a API service with a food delivery service like Zomato. If I will give you example of over here, API service is Zomato. So from Zomato, how you will do the order? So API service will call the order service through gRPC. gRPC, I told you already, it is a RPC command or protocol to do the server to server communication. So my API service will call the order service. Order service will place that order onto the cloud, and that cloud will make a call to ledger service. Ledger service will enter the ledger amount laser entry into its local database. Laser entry will be like of the credit and debit of amount whenever you are placing an order. So there is an amount associated with it, like 100 rupees or 200 rupees. So that kind of a laser entry will be into the laser service. And when we are ordering something, so there will be a call to the inventory service also. Inventory service will be again create an inventory into its local database. And when after creating an inventory, then we will place a order management also. So there are, like I will say, there are four services: order services, ledger services, inventory services, and order management. So whenever I am trying to call a API service which is Zomato, so at the background there are four services which were running parallelly, communicating with each other, and they are placing their data into the cloud. And cloud is a kind of a cloud database, and we have a like local database also with the services. Like the ledger service has its local database, inventory has a local database, order management has a local database. Order command does not have any database because it is accepting the order from API service and it is placing to the cloud. So this is a basic microservice architecture. Instead of designing a single service which is taking the laser entry, which is doing the inventory, order management, taking the order command, all these things, I segregated all these service into the different one. Because if because if my one service is down, my system is not down. Suppose my order management is not working, so in that case my order command is working, inventory is working, ledger is working, my app is not down, my app is giving the response. Because my order management is down, so it may be a case like I will get the order confirmation after 10 minutes, 15 minutes or 30 minutes, but my whole system is working. So this is the beauty of the microservice architecture. Like if any service is down, my whole system will not be down. So whole system will provide the response to the calling user. Like if I'm using Zomato app, so I order something, so my order will be accepted and my money will be debited, and I will give I will be given by a turnaround time. Like after 30 minutes, my food will be ready. So the meanwhile I can wait, but like my service is down, but after maybe 15 minutes it will be up, it will do its works, and my order will be ready after 30 minutes and I will get the delivery. So this kind of a microservice architecture is there in 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 any application. So you can design your application on the basis of this thing. You can break down your system into the smaller services. So the so this is about the API. So I'll show you about. Let me open Visual Studio. So I have a Visual Studio 2019 on my machine. So I'm trying to create a new project. So in new project, I will search. Okay, I'll tell you one difference also. What is the difference between .NET and .NET Core? Does anybody know about the difference between Core and .NET Core? Okay, so I'm assuming nobody has. So .NET application runs on only Windows application. So .NET application cannot run only on any other operating system like Linux, Ubuntu. So what should I do to run my application there? So to solve this problem, 2-3 years later ago, Microsoft introduced .NET Core. So .NET Core is provide me a platform where I can develop an application which can run on any platform. Maybe it is Linux, maybe it is Windows or Ubuntu. So here I am selecting ASP.NET Core Web Application, and here you will see C Sharp, Linux, Mac OS, Windows, Cloud Service. So if I'm selecting this one, so this application will be run on any kind of environment. And after creating application, so I'm giving some name like, so it is creating a ASP.NET Core application. So when I am trying to design a microservice, so I should use a API project. So API project will give me a template, inbuilt template, and here I can choose whether my API will be HTTPS or not. So right now I am unchecking it because my HTTP I'm not using it, and I will create. So it may take time to create this project. So project is basically created, and if I'll go to the controller, so here I have a controller, and its name is like weather forecast controller, and it has endpoint get endpoint HTTP get. So it is using HTTP get. It is returning me some weather data. So right now data is dummy. So this data is dummy, like date is dummy, temperature is dummy, and summary. So it is returning me some kind of a data, and data may be like some kind of, if I will try to run it, let me try if it will be able to run or not. It's taking time to up the service. So yeah, as soon as my service is up, so it is giving me some kind of a data, and this data is in the JSON format. So I'll show you this data is not in the correct format, like the readable format. I'll show you the correct one. So these are the data. Like we are getting the date like on the 30th September. We have temperature 37, temperature in Fahrenheit 198. So this kind of the response I'm getting from my
Excuse me, sir.
service. Sorry.
Sorry to interrupt in between. The screen is not visible. The data which you are telling us about, it's not visible in the screen, sir.
Okay, okay. Let me share it again. I think.
It's showing the references book slide only.
Okay, got it, got it. Let me share it again.
Yeah, sure.
So you are also not getting the Visual Studio also?
No, nothing. Your
Oh,
face is visible.
sorry. Let me share you the Visual Studio first. So guys, I created this application, web application in .NET Core. So how I created this application? Should I show you okay, from the beginning?
Yeah, sir. Sure.
Okay, okay, sure. Give me a minute. So I choose ASP.NET Core Web Application. Then I give some name. Then I click on Create. Then I select API because I am going to design as microservice. So I change API, remove HTTPS checkbox because my service is not secured right now. Then I created a solution. So in this solution, I have a weather forecast controller. So this is my weather forecast controller, and here I have a get endpoint. So get endpoint is giving me the temperature at different date of different cities in Celsius and Fahrenheit. So these are the dummy data. Like I have a static data, so I am for returning this data. So when I will run my service, when it will be up, it will give me the data. Now my Visual Studio is visible, or like uh, you are getting the web
Yes,
browser.
sir, it's visible now perfectly.
Okay. So let me show you my web browser. So after running my service, I'm getting this kind of the data on my web browser. So this data is coming. Now if I have to get the readable format of this data, so I will go to a online tool available for JSON viewer, because this is a JSON data. So I'll go to JSON viewer and I will open it. I will paste my JSON response here, and then I will go to viewer tab, and here I can get the data into readable format. So this is a different kind of the temperature I am getting on different date, like 14th, 15th, 16th, 17th date. I'm getting some temperature data, dummy data in form of like Celsius and Fahrenheit. So so this is all about microservice and by using .NET Core. So I created a .NET Core application here, microservice application, which is giving me the data in the form of JSON. I can add here more endpoint, and like here the highlighted one. So I am hard coding the data here also. So I can design another service which will give the this kind of the data from the service. So here if I'll create, okay, maybe I will create another project which will give me the service like temperature service, because this is giving me the forecasting data. If I have to get the temperature data, so I will create a temperature service. Temperature service will give me this data. So I can break my services to the granular level. Like I can be service will be a smaller service also. Like you can think about a service which will act only a smaller one and which give me only some data. So you can break your system up to any level. So that's it, guys, from my side about microservice and the .NET Core. So this is very small kind of the presentation which will give you some kind of the topic and word to go to the Google and to go to the online academy and will learn about the microservice and Azure, or maybe .NET Core. It will give you some kind of the like starting point to start your studies. Do you have anything to ask right now, or we can wrap up? Ayush?
Well, the participants, the podium is open for all of you. You can ask the questions if you have any. You can add in the chat box, or you can raise your hand. I can grant the rights to you to ask the questions then.
So I will advise all, you can go to the Udemy or you can go to the pluralsite.com. You will get a lot of data there, like the study material, and that will increase your skills about these topics definitely. I can ping the name here if you are not. Pluralsite.com, udemy.com. So there are like kind of the free material available also, like there are two kind of subscription, free and paid. So initially you can go for the free one. So for a student they provide for 1 month and 2 month like a free subscription. You can go there and you can study, and you have some kind of spare money, then you can buy the paid subscription also. That will increase your knowledge definitely.
Now, I would like to call upon Mr. Shas Gautam to give a vote of thanks to the speaker, Mr. Ankur Goel.
Thank you, Ayush. Thank you, Ankur sir.
Thank you,
First
sir.
of all, I'm very thankful that for a person who is non-technical like me, I had the brand MIT. I have absolute no technical knowledge, but the way you have explained, even someone like me could understand the nuances and the integrities of the topic today. So thank you very much for such enlightening and to the point presentation. We also thank you because we know it's a working day. So it was have been very difficult for you to take out time. So we thank you from the bottom of our heart to take out time for us. But as we say that, as you already said, that this topic is very deep and will need much more. We would love that, if you can come again and grace the occasion once again for us so that we
Sure,
can
sure.
go in the deep of this particular topic. I thank Naveen sir and Ayush for being so very persistent, because this webinar was to happen earlier date, but somehow it got delayed. So thank you, Ayush and Naveen sir, for your persistence that we were able
Thank you,
to
Shasji.
Thank you, sir.
we were able to get Ankur sir online. Ankur sir, thank you very much again. And as
Thank
I
you
said,
all.
Ayush will, and you have already said that you love Ayush, so we can take you for granted
Yeah, sure,
because
sure. Anytime you can call me, and if I have a spare time, definitely I
yeah.
will try to come again to MIT, or maybe
So
personally
I'm gonna
or
ask
online.
Ayush. I'm gonna ask Ayush to keep pressing you, because you have on record said it is live on Facebook that you love Ayush. So Ayush
Yeah,
will keep pressing you and
sure, sure.
and and get you back to us. So
Yeah, sure, sure. Definitely, anytime, anytime.
thank you, sir. Thank you very much.
So,
With
sir,
your
could I
kind
My
permission.
request you
pleasure.
to share your email ID? If somebody has any doubt, they can ask. They can ping you on your email
Uh,
ID.
so I'm trying my email ID on this session, so participant uh, can mail me. So this is my email ID, or maybe you can follow me on Twitter also. So this is my Twitter ID. Even I have a YouTube channel also where I impart some financial knowledge to my audience. So I have a good understanding of the financial market also. So if you do not would try to understand about technical, so you have some kind of interest in financial, you can keep in touch with me about the financial knowledge.
Thank you, sir. As I said, we are not going to leave you very soon. So you
Yeah,
are
sure.
coming back again.
Yeah.
So with your kind permission, I will like to wrap up the occasion today. Thank you all the participants, and thank you Naveen sir,
Thank you.
Ayush.
Thank you.
You are
Thank you
brilliant
so
as
much,
always,
Shasji.
and keep bringing such greats for webinars. Keep up the good work, Ayush.
Yeah. Thank you, sir.
Okay. Thank you.
Okay. Thanks. Bye bye. Thanks.